Hi everyone. This is very important question, Carnot cycle for CBSE students as well as Andhra Pradesh intermediate students and also for BSc physics students in thermodynamics. Actually, it seems to be a very large answer, but it is very easy to learn. I will explain this one to understand this question very easily. Here, first of all, see this Carnot cycle diagram. Here, PV diagram we taken. In this, the Carnot engine undergoes a reversible cycle, so-called Carnot cycle. Here, reversible process means that a process which can be reversed in such a way that all changes occurring in direct process are exactly repeated in the opposite direction in the reverse sense. This is called as reversible process. This is a Carnot engine works on reversible process. And what is a Carnot engine? A Carnot engine is a heat engine. It is used to convert heat energy into work. As almost all engines are heat engines, from that heat engines we are deriving work from that heat engines. Earlier days we have a steam engine. Here this is a Carnot cycle. This Carnot cycle undergo in 4 different process called as isothermal expansion, and the second one is adiabatic expansion, and then third one is isothermal compression, and fourth one is adiabatic compression. Here only by remembering this diagram we can easily write the theory and also derive that equations. Here see this Carnot cycle PV diagram. Here see this is a point A where the system has pressure P1, volume V1 and temperature T1, and we are doing isothermal expansion process. Here see this isothermal expansion process. Here isothermal expansion process means that in this process temperature remains constant, but what happen? Pressure will be changes and also volume will be changes. That is, in isothermal expansion the system absorbs Q1 amount of heat, and then the gas expands to a new volume from V1 to V2 and the pressure decreases from P1 to P2. Here this is isothermal expansion, so we have an equation for isothermal expansion is Q1 is equals to W1 is equals to integral V1 to V2 PdV. As we know that PV is equals to RT, and then we substitute here, we will get V1 to V2 RT1 dV by V. Here after doing this integration we are getting this one, Q1 is equals to W1 is equals to RT1 log base E V2 by V1. That is, whenever the system absorbs Q1 amount of heat, what happens? That working substance works, that is the gas works, so that the gas expands to a new volume from V1 to V2 and its pressure decreases from P1 to P2, and we get this expression. Very easy expression, remember this one. Q1 is equals to W1, that is the amount of heat absorbed is equals to the amount of work done by the gas is equals to RT1 log base E V2 by V1. That is, now the system is here at a point B. Here the system pressure decreases from P1 to P2 and the volume increases from V1 to V2, and temperature remains constant because of this process is isothermal expansion process. And then next process is adiabatic expansion. In this adiabatic expansion, just we are keeping the system on insulating stand, and it is allowed to move further adiabatically, so that its temperature is same as the sink temperature T2. So in this case, what happened here, further the volume of the gas increases from where to where, from V2 to V3, and also pressure falls from P2 to P3, and temperature increases from T1 to T2. Here remember this one, this is an adiabatic process, so that no amount of heat enter into the system and no amount of heat leave from the system, so that here the gas itself doing work in expanding, so that what happened, its temperatures falls from T1 to T2, and pressure falls from P2 to P3, and volume increase from V2 to V3. So that here in this case the work done by the gas is W2 is equals to V2 integral V2 to V3 P dV is equals to integral V2 to V3 K into dV by V power gamma. How we got this one? As we know that in adiabatic process we have relation PV power gamma is equals to constant, that is PV power gamma is equals to K. Then we are getting this one. Here you should remember this one only that is only W2 is equals to R into T1 minus T2 by gamma minus 1. That is after integrating of this one we are getting, this is the answer, W2 is equals to R T1 minus T2 by gamma minus 1. Very easy to remember this one. See, this T1 is always high than the T2. So R into T1 minus T2 by gamma minus 1. This is the work done by the gas. Now see this. Now the system is at a point C. Here now we are going to brought the system to its initial position, that is A. That is we have to increase its pressure from P3 to P4 and then P4 to P1. Here in this case the gas does not work anymore because of totally the pressure falls from P1 to P2 and then P3. That is the pressure of the gas is very much less, so that it can't work. So that here in this isothermal compression, that is we are compressing the system, that is the gas is under the compression very slowly by putting its temperature remains constant as T2, so that what happened, the amount of Q2 is rejected from the working substance to the sink. Sink is usually we are using as surroundings, so the Q2 amount of heat, here see this Q2 amount of heat is rejected to sink. This amount of heat is equals to the work done W2, W3, that is we are working on the system. That is nothing but Q2 is equals to W3, which is gives rise to integral V3 to V4 P dV. This is isothermal expression. You always remember in isothermal expression we are getting RT log base E V by V. That is we are using this like V4, V3 and so on. After integration we are getting. See this here volume. What happened when we are compressing the gas? What happened? Volume decreases from V3 to V4, from V3 to V4, and pressure increases from P3 to P4, and then we are getting this equation as Q2 is equals to RT2 log base E V4 by V3. You remember this equation only, no problem at all. So Q2 is equals to W3 minus RT2 log base E V3 by V4. Here see this, we are reciprocal this volume, so that we put here minus. And then next to brought the system to its initial state. Yes, it is a reversible process, so how to go to its initial position, we have to do a process called adiabatic compression. Here adiabatic compression means further we are compressing the gas, so that what happened, its temperature rises from temperature T2 to T1. See this is the isothermal compression, so the temperature remains constant. Here it remains from C to D. Only when we are going from D to A, what's happened? Its temperature rises from T2 to T1 when the system undergoes adiabatic compression. In this adiabatic compression, we are using this one formula. See this, W4 is equals to integral V4 to V1 P dV. That is a volume decrease from V4 to V1. Here in this case, as we know that PV power gamma is equals to constant, we are substituting, and then we are getting the answer W4 is equals to minus R into T1 minus T2 divided by gamma minus 1. Just you simply remember this equation. No need to remember all the equations. Just W4 is equals to minus R into T1 minus T2 by gamma minus 1. Now here, see once all the equations, see this first equation. Q1 is equals to W1 R T1 log base A V2 by V1. See this is the equation similar to equation, that is equation number 3. See this, Q2 is equals to W3 minus RT2 log base E V3 by V4. Here the difference thing here no minus, here minus, here T1 and here T2. Here log base E V2 by V1, here log base E V3 by V4. We are getting here V2 by V1, we are getting V3 by V4. Equation same, RT log base E and the volume. Here see this once again I am saying Q1 is equals to W1 RT1 log base E V2 by V1. Here RT2 log base E V3 by V4. Here, and the second one thing is W2, see this RT1 minus T2 gamma minus 1, and see this W4. Here minus RT1 minus T2 by gamma minus 1. See this equation, this one 2 and equation number 4, both are same, but this one is a negative sign. So that W2 and W4 are both same, so they get cancelled. To get the total work done, we are going to be sum of the all works, like W is equals to W1 plus W2 plus W3 and W4. Here see this, as we know this W2 and W4 are same, so they get cancelled. Remaining we have W is equals to W1 plus W3. Then we substitute this equation, we are getting W2 is equals to, that is W is equals to RT1 log base E V2 by V1 minus RT2 log base E V4 by V3. That is W is equals to total work done is equals to what is that? W1 minus W3. Here W is equals to W1 minus W3 means that here Q1 minus Q2. As we know that Q1 is equals to W1 and Q2 is equals to W3. Now the efficiency. Here what is efficiency? What is its definition? Here efficiency is indicated by letter neta. Here this neta is equals to work done by the engine divided by heat taken from the source. Here work done by the engine, that is W, and divided by heat taken from source is Q1. Here as we got W is equals to Q1 minus Q2, and then right here Q1 minus Q2 by Q1, which gives rise to 1 minus Q2 by Q1. Here see this, and we are getting the answer as neta is equals to 1 minus Q2 by Q1. This is the efficiency equation in terms of heat. Now we have this efficiency equation in terms of temperature by considering adiabatic course on the PV diagram. Here see this. Here this is the PV diagram. Here this is the PV diagram. See this. This is the PV diagram. Here we have two adiabatic lines. That is, one is BC and there is DA. Here see this. Here this is the BC as adiabatic line, and DA is another adiabatic line. Here see this in BC adiabatic line, as we know the relation, that is TV power gamma minus 1 is equals to constant. Here see this first one, T1 V2 power gamma minus 1 is equals to T2 V3 power gamma minus 1 for BC adiabatic line. How we got this one? See this, at adiabatic line, here we have T1, and we have value V2, that is T1 V2 power gamma minus 1. And then next at C you see this T2 V3, that is T2 into V3 power gamma minus 1, that is the temperature and values and at BC is like this: T1 V2 power gamma minus 1 is equals to T2 V3 power gamma minus 1. From this we are getting T2 by T1 is equals to V2 by V3 gamma minus 1. From this is the BC line, and then we have another curve, that is DA. Here from DA curve, see this, we have temperature T2 and volume V4, that is T2 V4 gamma minus 1, T1 V1 power gamma minus 1. See this here is T2 V power T2 V4 gamma minus 1 and T1 P1 gamma minus 1. From this we are getting T2 by T1 is equals to V1 by V4 gamma minus 1. Here by equating these two equations, see this, we are getting this one. See this, V2 by V3 gamma minus 1 is equals to V1 by V4 gamma minus 1. From this we are getting V2 by V1 is equals to V3 by V4. Here this equation, the substitute in the work done equation, that is W is equals to RT1 log base E V2 by V1 minus RT2 log base E V4 by V3. Here in this case V4 by V3 we have. So in this V4 by V3 we are going to substitute what? V2 by V1. Very easy. Now here see this equation, W is equals to RT1 log base E V2 by V1 minus RT2 log base E V3 by V4. As we got here in the earlier this equation, Q2 is equals to W3 minus RT2 log base E V3 by V4. As now we got V3 by V4 is equals to V2 by V1, so that we are putting this value here in this case V3 by V4, instead of this we are putting V2 by V1. And then here what happened, now this equation, when we putting V2 by V1 here, we are taking common, or T1 minus T2 log base E V2 by V1 we are getting. Here this W value substitute in the efficiency equation, eta is equals to W by Q1. Here see this, R T1 minus T2 log base E V2 by V1. And then what is Q1? In the first equation we got, in first equation Q1 is equals to W1 is equals to RT1 log base E V2 by V1, and we are substituting here. Now what happened, cancels, and then we have neta is equals to W by Q1 is equals to T1 minus T2 by T1, and then neta is equals to 1 minus T2 by T1. Here this is the efficiency equation in terms of temperature, and I done this one each and every step very clearly. If you have any doubt, ask me, I will explain in the comment section. And whoever going to be write in the public examination this question must remember the rounded part, that is that formulas we got as equation 1, equation 2 and equation 3 as equation 4. These are the very important. Just you remember only these answers and some of this theory, then you will get the full marks. Q1 is equals to W1 is equals to RT1 log base E V2 by V1, and Q2 is equals to, that is W2 is equals to RT1 minus T2 by gamma minus 1. Here in this case Q2 is equals to W3 is equals to minus RT2 log base E V3 by V4, and then W4 is equals to minus RT1 minus T2 by gamma minus 1. Here this is the very important question, don't miss it. You have any doubt, ask me in comment section, and also you yourself practice once the equations only, then you will feel this is a very easy answer. Thank you one and all.